Starting here with part D, we're going to look at kind of that idea of that distance from a number line. So if I look at 8, 8 is 808 from the number line, and I can just go ahead and I can graph that point 8, 8. If I have a point that is 5.6 away from the number line, that means my x value could have been 5.6, but it could have also have been a negative 5.6. We don't necessarily know which one it actually came from because they both are 5.6 from 0 on that number line. So when I'm graphing that one, I'm going to put in both the positive and the negative versions of those. And I'm going to do the positive 5.6 and goes up 5.6 because they are both the same distance away. So if I give it to you in the x value, there's only one answer it can possibly be when I look at how far apart it is. This case is going to be pi, which is about 3.14. So I'm going to go a little bit past 3, and then same thing on my graph. Same thing with a half. A half is going to have going up to be a half, so 0.5 goes up 0.5. But if I'm giving you 1, I have two numbers, both 1 and negative 1 are away. I don't know exactly what number it was supposed to be. Looking at 0, that's still 0 away. It's right on that point. Negative 1/2 would be a 1/2. Negative 1, we already put that one up above, but we know that's 1. Negative 5.6 is 5.6. Again, our 8, we already have 8 on our graph, but it could have also been a negative 8. We just don't always know which one came from those. And then if I were to sketch in my graph, I'm going to fix this one point that had to be, a little bit off on my graph. Just because now I can see all those points, I know where things should be on our graphs. So writing a rule for this, we're saying that we've two different people writing, and Andre is saying it's a kind of a piecewise function, that it's going to be x or whatever number you started with as long as x is greater than or equal to 0, and negative x as long as x is less than or equal to 0. And then Elena's writing the absolute value of x. Really, they're the same thing. It just says that whatever we have, we're just kind of looking at that positive version of those, and that you're kind of writing a little bit more on that bottom part. Graphing these. If you don't have a graphing calculator at home, you can use the Desmos calculator. So that would be my recommendation. If you have a graphing calculator, use the graphing calculator. We are changing the values of A to get to the absolute value function on the graphing calculator. So Desmos, you can just type in the little bars. It's like below the delete key, hit shift. But if you are looking at the graphing calculator and you want to be able to type in the absolute value piece, you on your calculator are going to go to math. And the math button is right below the green alpha button. So you type in math, you're going to arrow over using the little arrow key to where on the top it says NUM. That stands for number. And we want number 1, ABS. So you would do this in your y equals function, and that will help to give you a graph of that particular piece. And then depending on the version of your calculator, sometimes they'll put them in parentheses. Sometimes you'll see the absolute value. You're doing this very much like what you did before with the quadratic functions, and we're just seeing what happens to A. Does it do the same as quadratics, or does it do something different? Same with B. Does it do the same, or is it something different? This is very much like what we did, the finding patterns, and used it as a pattern summative. So as you're writing up these answers, be super specific, and again, treat it as though you're writing it as for that pattern summative, and then this goes into classroom when you're done.